Hello everyone, thanks for coming and welcome. Today we're going to be talking about disaster recovery for 2013 and Azure Site Recovery. This actually qualifies for SharePoint 2016 as well, so this will be relevant going forward. Just a little bit about me. So my name is Eric Harlan and I am quite a few things, some good, some bad. But on the good side, father, do some writing, speaker obviously. I'm a big skier when I'm not working or doing the family stuff. Usually you can find me in the snow on some hemisphere in some mountain somewhere. I'm located out of Las Colinas, Texas, at the Microsoft office out of Las Colinas. And basically just a SharePoint PFE there. So what PFE means basically is it's basically tier 4 for SharePoint support, or support for any SharePoint product for that matter. When you don't want to go through the queues, or you have a really sticky issue, or you just have a Premier contract and it affords you to skip all the phone conversations and that sort of thing, you can go directly to Premier, which will assign someone like me to either come out on site and sort things out, or do some custom training, or pretty much anything across the stack that we can support. Or it will allow you to connect with a PFE directly, so no more escalations and that sort of thing. So that's what a SharePoint PFE is at Microsoft, and let's get on with it. So why are we here? So the first thing we're going to be talking about with disaster recovery is really, what is it? Quite frankly, there's a lot of conversation and speculation about what DR actually is, and some misconceptions about what DR actually is. So we'll clear up some of those details. Talk about some of the terms. We'll also walk through a couple of different DR scenarios that come up that I've personally seen in real life, which are pretty interesting. And then we'll get into talking about some of the different disaster recovery tools available to you in Azure. So this is actually going to be the meat of the situation and what we'll be talking about, so hang on tight there, and then we'll be having a demo here at the end. And then obviously at the end of our talk we'll have some time for conversation as well. So what is disaster recovery? It seems like a pretty simple question, but at the end of the day it's really not. DR, or a disaster, is total loss of data or service. A lot of recovery times average between 1 hour and nine-ish hours, depending on the level tier priority in that organization of what SharePoint is. So if it's a corporation that runs, let's say, a line of business that directly impacts sales on a customer-facing front end, that's going to be much more valuable to get up and running a lot quicker than something like a small business who has a little bit of collaboration here and there with different content. Now, one of the big things that kind of came out, and I believe it's Gartner, don't hold me to that, but I believe it was a report from Gartner saying basically that of those Fortune 500-ish type companies where SharePoint was a tier 1 application, on average, and this was not the high end and it wasn't the low end, but on average it was about $1 million per hour of downtime. So every hour that a tier 1 app like SharePoint is down, when it directly impacts either workloads or consumer purchasing availability and that sort of thing, about $1 million per hour. So that will start to set the stage for what true DR actually is. So of those companies, almost half of those businesses never actually reopen, or they have such a dramatic impact in downfall that they actually have to either close up shop, or they rebrand, or whatever it might be. Now this isn't just SharePoint, right? So this is just tier 1 applications where consumer or workloads themselves have been directed. So this could be any real application. So what does that mean for what true DR actually is? So DR is not VM snapshots. DR is not off-site tape storage, and it's certainly not something where you have to physically drive or physically go, or even pull data backups from something like database backups. So think content databases for SharePoint. That is not DR. That's a recovery strategy. But when you talk about DR, you need something to the effect of near real time, if not very fast, depending on what the SLA requirements are for having that tier 1 application up and running. Recycling that environment and bringing it up to speed, bringing it up to where it can actually handle workloads in real time. So either one click or automation or whatever it might be, with very, very minimum to zero data loss. That's why we say that snapshots and backup databases and that sort of thing, they're not DR, right? So you're going to lose something along the lines. Now, it doesn't necessarily mean that these strategies that aren't really DR don't work. It just means that there are some dramatic costs or pros and cons to sort of weigh out based, again, on the SLA requirements of how much that application needs to be up and running. The biggest inhibiting factors of actual true DR, so again, near zero data loss and minimum downtime, are really just two things. They're cost and complexity. So it either costs a whole heck of a lot, or it's very, very complicated and risky. And we'll talk about why some of those things happen and what ways that we can mitigate those. So typically with SharePoint related conferences and discussions, it's mostly SharePoint that we talk about. And in this case, it's kind of SharePoint sprinkled over Azure, right? It's a lot more Azure than it is SharePoint. It just so happens that what we're about to talk about, as of Ignite 2015, officially is supported for SharePoint 2013 on-prem. And again, this will be going forward, I'm sure, for 2016. This was not the case for a long time. So Azure Site Recovery came out sometime, I believe, Q3 of 2014. It was available through the acquisition of InMage and some massaging of the product and rolling it into Azure. And it was available, so you could do it on Windows platforms across the board or Linux platforms across the board, but it wasn't necessarily supported from the SharePoint product group perspective because they had to vet it all out. Well, that's been vetted. It's actually a very extensive process that was gone through, and we almost had it ready a couple weeks before Ignite, but we announced it there. So most of what we're going to be talking about going forward, it's mostly Azure, but it's directly relevant to SharePoint, and I'll sort of frame the conversation about Azure Site Recovery around SharePoint. So a couple quick DR terms that we'll just put out there for everybody. So RTO and RPO. RTO is recovery time objective, RPO recovery point objective. So recovery time is exactly what we were talking about. Of this tier level application, what is the requirement that I either need to have SharePoint back up and running, or that the span of time where it's actually out fits within the 99.99 whatever percent of outage that we allow. And when I say we, I just mean any organization. And then RPO, recovery point objective. So at what point in time are you okay with losing data, right? So with DR, it's very difficult to have zero loss of data. It can be done with Azure Site Recovery and some other different scenarios within Azure and with on-prem and things like Always On and different data centers, which are all available through Azure in some way, shape, or form. But we'll be talking about specifically Azure Site Recovery today, and we'll tell you why we're talking mostly about that as well. All right, so let's talk about some of those DR scenarios that I've actually seen. So believe it or not, I've actually been in an environment where the day that I arrive, there is air conditioning loss in a data center that's on site. So at one point in time, as things are trying to be shut down gracefully and the temperature is rising, they're bringing in fans and that sort of thing. At some point, they get to the realization that they need to shut down stuff really, really fast. They start literally yanking plugs out of the back of production servers. So database servers, web front-end servers for SharePoint, you name it, it's getting power yanked from it. If not, it's going to melt. So I've literally seen that. I've seen, thankfully, I wasn't physically there when it happened. I've actually seen burst sewage pipes running into data centers. Not sure who thought, it was a good idea to run sewage or any kind of piping around a data center, but there you have it. More common scenarios, natural disasters, fires, floods. Again, being from Texas, we're dealing with quite a lot of rain right now. Hurricanes, typhoons, tornadoes, another thing that we have to deal with out here. Most oftentimes, it's either civil unrest, again, power outages, just something haywire happened, or even, someone nexted something in a prompt and didn't pay attention to exactly what they were doing. And that's usually the case. I mean, most of the time it's a mistake or, something, just a blip happens. But at the end of the day, it still happens. So how do we recover from those types of things? So there's a couple different ways within Azure, and these are not the only tools that are going to be available to do it, but there's a couple different ways within Azure to do different types of disaster recovery. And again, this isn't the whole story. There's things like IaaS VMs that are running always on in Azure real time, but you start weighing out the pros and cons of costs versus the feasibility that you're actually going to have a DR situation come up. So what we're going to be talking about specifically today as it relates to DR is, in my opinion, currently the best way to do any DR, to be honest, in the Windows stack currently. So when I say any DR, I mean quite literally. We've done a survey of all of our competitors, and the nearest competitor was something like, $750 per VM or per machine per month, right? So that gets really, really expensive when you start talking about large tiered SharePoint environments, multi-tiered environments, multi-farm environments. Think consuming farm and publishing farms and dev and test, and then maybe a services farm. Things get very expensive very quickly. So in my opinion, ASR as of right now is probably the best solution for the cheapest, and you'll start to see how that picture unfolds here in a bit. So some of the pros to Azure Site Recovery. So Azure Site Recovery at the end of the day is a way to replicate a machine's state up into Azure one delta at a time. That's probably the best way to explain it. Okay. Now, interestingly enough, it's supported by multiple different, or Azure Site Recovery supports multiple scenarios and platforms. So you might have heard me say that it supports Linux and Windows. That's the case as well. Obviously, we support Hyper-V. We also support VMware. And interestingly enough, we support a physical server to replicate into Azure, and we'll talk about how that sort of happens here in a bit. So some of the supported technologies: Always On, Hyper-V, System Center for automation, vCenter. We have VMware, SAN replication, and again more. We have things like physical, which is in it's either private preview or public preview. Actually, it's not public preview because it's not readily available right now, so you have to request access to that, but you still can do it. So it can be near synchronous or synchronous. It sort of depends on your requirements. There are ramifications cost-wise, deciding on which you pick. So it's really whatever is relevant to the business. So one of the biggest hurdles that I come across from a an engineer perspective, when I'm trying to have this conversation with many of our customers, is what is the true SLA? What is, it's easy to slap 99 point, a million nines on a document and say that's our SLA. But at the end of the day, if everything went down in your environment and you had to do a complete restore, where does SharePoint fit into that? And what's acceptable for downtime? Is it literally minutes? Is it 2 days, a week? It will all depend on scenarios, and those are the conversations that you have to have before you go down this road, because the outcome of those conversations will dictate the way that you approach doing disaster recovery with ASR. So the good thing about ASR is that it's single button true failover. So once everything is up and configured and working properly, it is a matter of pressing a single button in Azure or having an automation script run, or automation scenarios run within something like System Center to fire off a failover, and you don't have to do anything else. Azure Site Recovery handles all of it. You don't have to touch it. You don't have to worry about it. At the end of the day, it's very, very cheap insurance. We all carry car insurance or homeowners insurance or whatever. At the end of the day, we hope to never, ever use that stuff. But if we do have to use it, we know that we're covered for most of the major costs that come down the road. So it's really just in case something happens insurance. And how this all relates is because it's super, super cheap. So like I said, you heard me say, our closest competitor, which even comes remotely close, which doesn't have the full feature set that we have in Site Recovery, was $750 per month per instance. In Azure Site Recovery, it is $54 per month. So a small SharePoint environment consisting of 2 web front ends, 3 app servers, an always-on availability group, and looking at that from a cost perspective, at the time of this recording, it was roughly about $378 just to have that insurance in case a failover situation happens. Okay, that's not the total cost, and it's not very complicated. I know some things with cloud pricing can be a little bit complicated, but at the end of the day, it is very, very close to that cost, and I'll tell you where the variations are. So the way that Azure Site Recovery works, in a nutshell, is that depending on the scenario, whether it be Hyper-V to Azure, whether it be VMware to Azure, whether it be physical to Azure, or a mix of those two, and even if it's on-prem to on-prem, because Azure Site Recovery is embedded in things like Azure Pack that allows you to install Azure features within your own data centers to connect to data centers that you own on-prem in your own facilities. The cost doesn't really rise up from that. So if you have an EA agreement, plus or minus, I'm not a licensing expert, quite honestly, I don't know anyone who is, you have 100 gigs of storage for free, and you have 100 gigs of failback data transfer for free. So how this sort of works, and I was getting at that here in a second, was you synchronize your VMs or physicals or SANs or whatever they might be up to Azure. So let's say you're working with, let's say for instance, Hyper-V. So Hyper-V, you have VHDs, you have Gen 1s and Gen 2s. You synchronize your VHD using a process tool that you install on the VM host. That has to be 2012, I gave away one of my slides, but it does have to be 2012 R2. That's the downfall, because quite often there are tons and tons of VM servers running on a VM host, and they are usually 2008 R2 servers. So it does have to be upgraded. That's the only downfall, unless you're already there. Once those VMs are synchronized, they are stored within Azure Storage. So the cost to store things in Azure Storage is very, very cheap in comparison to running, let's say, a SQL Azure VM in real time. So you're paying for compute time and processing time and all that sort of thing when you're running with the VM, But when you're just storing a VHD, which is in theory a flat file, to Azure storage, you're just paying for that storage. So if you have that EA agreement, you're looking at 100 gigs of storage free. That's not really a whole lot when you consider large tier 1 environments for SharePoint, but at least it gives you some free. And then again, it's pennies on the dollar for how much it costs for storage. The only time you incur any other cost, before I get into that, let me just quick mention $16 per instance if you're doing on-prem to on-prem. So if you have VMware in one data center and one VM host, and you want to use Azure Site Recovery to fail over to another VM another VM host, or Azure within Azure Pack on-prem to on-prem, so 2 data centers that you own, it's only $16 per month. So this wraps all that ASR technology up into a bundle and lets you do the exact same thing as you're doing with Azure in the cloud, whether it be government Azure, whether it be commercial Azure, doesn't matter. And it lets you do that in your own data center for even cheaper. So $16 per VM, per machine. That's super, super cheap when you put that in context to a real outage where you might be facing a ton of data loss and a long time down. So again, back to my original point, the only time you incur any other cost is when you have a DR situation happen and you physically have to fail over. Because then what happens, the whole time you're pushing data, Delta data from your VMs into Azure storage, and you're not getting charged for that. It's just you're pushing data in, you're just getting charged for the storage itself. If you don't go over 100 gigs, no problem. Once you hit failover and you hit that single button and you fail over, what Azure Site Recovery does is it takes those VMs out of storage and spins them up into Azure VMs, does all the networking transformations, pushing all the network data across, and then you're quite literally running your farm that was on-prem that until 30 seconds ago just pushed its last delta up to Azure. That VM got spun up, all your traffic and your DNS entry stuff got pushed over to Azure, and now you're serving up that content to either your external org or your internal intranets, all fully secured and in real time. So there's very little data loss. And when you're done, you fail it back essentially. And then the only other time you essentially incur a cost there is when you're pushing the delta of what changed while your DR environment was up and running. So let's say someone uploaded a 3 gigabyte file or 3 megabyte file. That delta gets pushed back down. So you do get charged for downloading from Azure. But at the end of the day, let's say if it's up for an hour, if that's your SLA, and barely anyone used it because everyone's shuffling around to get stuff up and running again, you might really only incur a very small cost, just basically what the VMs cost for that hour of running, which depending on what you choose that VM to run as can be fairly significant or very cheap. It all depends, and I'll explain a little bit of that going forward. So we have data costs, which I gave away the entire slide. So again, just to recap, you're doing full sync VHDs over the wire. You're pushing those deltas up after that full sync has occurred, and then the only thing that's being stored is the VHD and Azure storage. And there's also some third-party tools like Riverbed, who has a white paper with the Azure ASR team on compression of VHDs. So even that first initial hit, let's say you're in the neighborhood of a couple terabytes of data, when it comes to the VMs themselves. We also support things like Riverbed and different compression tools to get that down really low, or as low as it could be, to make that journey from on-prem to Azure. So you can even still reduce your cost that way. So a few of the cons, and depending on how you look at it, they're not really cons. So you do need a connection, and the connection is dependent on the type of scenario that you choose. So if you have just a VHD scenario where you don't have any physical machines running, you could in theory push this all over public internet pipe. So just your normal internet that you have going into your office, into your data center, you can use that to push up to Azure. Now obviously the downfalls of that is security. You have issues with latency of bandwidth, If you're doing it in peak times, other people are doing their normal work, and that could slow performance down if you have a critical situation where you have to get stuff up into Azure quickly. If you're doing physical to Azure, you have to have a site-to-site VPN in place, because the machine that you're running whatever on, SharePoint in this case, has to understand that that's part of the extended network up into Azure. So it has to trust that and send that over. The benefits of that is you're getting some more security out of it. You're still using your normal pipe to push that across, but there's pros and cons to that situation. And then you have ExpressRoute. So ExpressRoute in itself is not a con. In fact, it's really awesome. The problem is it's really expensive too. And what ExpressRoute basically is with your ISP is a direct pipe to the Azure data center. So I've heard different variations of costs, anywhere up to $10,000 per month per pipe. You factor in a couple different data centers going to Azure at any given time, that bill goes up really, really fast. But it could, in theory, pay for itself. Depends on how much data you're pushing across and the speed in which you need it there. So if your SLA is, again, minutes, and if it's down for 10 minutes, that equals $10,000, then right away, you've covered the cost of what it would cost for ExpressRoute to get that stuff up there much quicker. Depends on how you look at it. So right now, the Azure Site Recovery product group doesn't support VHDs X or Gen 2 VHDs yet, and that's a big yet. So what's actually happening, and doesn't mean you have to convert them to VHD to make this work, is Azure Site Recovery will convert that for you. So it'll push that up it'll take that VHDX, push it up to Azure Storage. As it does, it's converting it to a VHD. If you fail over, no problem, it's up and running. Once you fail back, the agent will actually convert that back to a VHDX so that you can remount that in your local VM host. So at the end of the day, it's not a whole lot lost, except for the fact that if you have any features that are VHDX or Gen 2 supported that are not supported in Gen 1 or VHD, then you lose that feature. That's the only thing you have to plan for going into that. And then, like I said, Physical to Azure is in private preview, so you can go check that out. You have to send a quick note through the Azure Site Recovery page out on, I don't remember the exact URL. I should probably post that up. I'll have that ready for the Q&A. And you can push that out, or if you have a PFE or dedicated PFE that you work with, you can get in touch with them and they can make that introduction for you. And basically it comes down to they just want to know a little bit about the business, how things work, see if it's a good candidate for basically beta, and then they'll push that down to your subscription. So I talked a little bit about physical. So when you have physical to Azure, there's a couple other things that are happening. There's a mobility service that is installed on each physical machine, and that basically intercepts those changes and sends it to a process server. Then the encryption happens, and that sends changes to a master target server. And these are big terms that really don't mean anything in the context of just what it is about the technology, but these are specific terms that when you're setting up Azure Site Recovery in Azure, you'll have to configure. So if you're running physical to Azure, you have to have a config server. So the config server is an actual VM that's running in Azure. It's very small, very low cost, and the site recovery wizard will actually build it for you. So you just have to fill in a couple blanks, and I'll show you in that demo what that looks like. But that is required if you're going physical to Azure. So that's one ramification. And why would someone want to do physical to Azure versus VM to Azure? A good scenario that I see a lot is, let's say you have a mixed physical virtual environment for SharePoint, where on physical you have something that's carrying a heavy I/O workload, something like indexing of SharePoint content, right? So maybe you haven't taken advantage of the 2016 stuff yet, where you can offload that search up to 365, and you're doing all that stuff on-prem. So let's say you've chosen to use that server as a physical server. So basically what happens is now you have some web front ends, some maybe other application servers that are running in virtuals, and then you have these couple physical servers that are running. Maybe SQL is one of them as well. So that's a case where you might have to think about a multi-tiered methodology and how you push your DR stuff up to Azure. Now, the tricky thing is coming back. So coming back from a physical to Azure, you failed over, and now there's a delta change between what you pushed up to Azure initially. You had a DR situation, you failed over. Let's say you were out for a week, right? So all the changes that have been pushed to that server over that course of a week, Azure converted that physical box, as you would imagine it does because it's a virtual service. It converted that physical box to a VHD. Behind the scenes in Azure Storage, if you look at your VHD storage, that physical is now a VHD. So in Azure, it was running as a VHD. Again, it's a completely virtual environment. You can imagine it would have to run as a VHD. Otherwise, Microsoft would have a data center somewhere where it's replicating physical boxes to become more physical boxes. That doesn't really make a whole lot of sense. All well and good, no problem during the failover. The issue comes when you fail back. So failing back is a little bit tricky because you are taking a physical that went to a virtual, and then you're coming back down to what presumably you would think to be a physical server. In actuality, because from a technical perspective, taking a VM and unfolding it and creating a physical box from that VM is fairly difficult if you think about it. I mean, you can boot to a VHD, and that's kind of sort of like that, but it's not really the same, right? So you're not at a kernel level, you're not reproducing that physical box from a VHD. So when you come back down and you fail back, Azure will push a virtual representation of that physical box as a VHD and all the changes that happened during that outage. And that sounds like a game changer, that sounds like almost a roadblock, but it's not really if you think about it. I mean, we've done this a lot where we add servers to a farm, right? So the environment fails back, everything's up and running automatically, and now you have what was an index server physical is now a virtual. Okay, well, you probably lost that physical server anyway in the DR situation, or something was corrupt, or it's been so long since it's been down, it doesn't even matter anymore, the index is out of date. So you repave a server, you install SharePoint back on it, and you add it back to the SharePoint farm as you would if you were scaling out any SharePoint farm. And then simply offload that workload that was physical and went to Azure and then came back as a virtual. You offload that workload that's now carrying that to the new physical box that you've stood back up and pushed back into the SharePoint farm. So it's an extra step, but let's be honest, at the end of the day, if something disastrous happened in the first place, it's really one of the least worries that you have to consider. And just quickly, if you choose so, you can check out what the requirements are for the box to make sure that you can do a physical to Azure failover in the first place. So a quick tutorial walkthrough of doing physical to Azure, and I couldn't really do this in the amount of time that I wanted to do it because you actually had to have a physical box and a virtual machine box running up in Azure at the same time. It's very complicated to do in the amount of time that we have. So I'm going to walk through a couple screenshots of what it's like to set up physical to Azure, and then we're actually going to do a video demo of what it's like setting up virtual to Azure, so you get the idea. So first things first, you're setting up a new site recovery vault. So this is under the site recovery tab within Azure, and this is the bucket in which everything for your disaster recovery situation, all the VMs, all the network settings, and that sort of thing are going to be stored into. Next, you have a target. So you have to deploy the configuration server, like I talked about. It's a small little server that runs in Azure IaaS. And this is literally the configuration. It's very simple. What is that? 8 checkboxes, 9 fields or something like that. So just giving it a name, selecting the network that you've already configured. By the way, you've set up the network already, a virtual network within Azure, and you've done all this work previously. So, I mean, unless you're setting up Azure for the very first time and the very first thing you did was ASR, then you obviously wouldn't have this information yet, and you'd have to do the virtual network configuration stuff first. And then, like I said, it has to have a VPN, right? So you have to go ahead and set that VPN up on that environment to make sure that you can do that physical to Azure. So again, if you take notice of these screenshots, they're numbered. And the screen that you'll see in the video demo is numbered as well. So it's very simple. It's a no-brainer of the items that you have to walk through and the order that you have to walk through. So then you're adding the machines themselves to a protection group. So a protection group is sort of the bucket within that vault that dictates what type of machine is going to be created, what is going to spin up in what order, and that sort of thing. And the cool thing is that you can set up, let's say your web front end server, web front end 1 failed over, right? Let's say on-prem you have maybe 4 web front ends, and they're running on, 12 gigs of RAM and 4 procs. In Azure, you can play with different scenarios to either dumb down the performance or speed up the performance, as well as scale back the price or scale up the price. And why would you want to do that? So a really quick scenario, let's say you have those 4 web front ends and they're modest on resources, but in Azure you can say it costs less, for instance, to run 2 A4s than it does to run 4 A3s, right? And an A4 has more resources. It's going to handle the load that you think you're going to have in the meantime of having a DR situation, because maybe the last thing you have to really be concerned too much about is keeping optimum performance within your SharePoint environment when there's a DR situation. So maybe your SLA just says we have to require access. It could be a little bit slower, it could take a little bit longer to upload something or run a report or whatever it might be. And doing so and choosing the appropriate sized VM template when the VHD from Azure Site Recovery Storage is applied to Azure IaaS and that VM is spun up, you could probably even save money on just spinning up less machines. Now, you have to play with a lot of different settings to make that happen, but at the end of the day, you could, in theory, do that. And then you run a failover. So you just go to your vault, and you can check or click a link, and then it'll literally come up with a little page here. You can choose what the name of that recovery plan is going to be, hit OK, and then run a failover, make it happen, and test it to make sure it actually works. So that's all well and good, but the other issue, we talked about cost. The other problem with DR is it's complicated and it's really scary, because to test it and make sure that it actually works, and when a PFE comes in and says, have you run any DRs? Have you tested it? Are you absolutely sure it works? You can absolutely say, yes, I know it works, because ASR actually lets you test a failover and never brings down your production on-prem environment and never diverts traffic away from that environment. So what Azure will do is take all the VHDs that you've synchronized, spin them up, do some local virtual networking. So you basically have your synchronized VHDs from on-prem in Azure Storage, and then the connection, in lack of a better way to explain it, although it's not cut, is cut off from your production environment, so it doesn't draw from that, it doesn't redirect any traffic. That all stays up, no one even knows you're running a test, and then Azure will spin up those VMs, run the test for you, and you can actually see your production environment come up in Azure in a test scenario. And then when you're done, you just turn it off, you fail it back, and it crushes down those VMs. Now you're paying a little bit of cost for those VMs to get spun up and to make sure it actually works, but if you're bound by different type things where you have to be ISO compliant or whatever it might be, then you may have to do that anyway and have to figure out how that it's actually going to work for you. So at the end of the day, it's worth the cost. So we talked about ExpressRoute being really cool but really expensive. We talked about a couple of different things associated with it. Here are some of the requirements that comes along with making sure that you can actually get a ExpressRoute pipe put in. Obviously there's a lot of collaboration and purchasing that goes on with the ISP and all that good stuff, but these are the technical requirements. From a site-to-site VPN technical requirements, there's actually very little that you have to do. So it's pretty quick, and I think to run a site-to-site VPN, it's something like $25 or $28 per month. So in the grand scheme of things of security and making sure that the network is just extended into the Azure environment and everything knows where everything is, and you can connect different farms and different machines to that network in Azure or on-prem, $28 is, again, not a whole lot of money in the grand scheme of things. So that's all well and good, but everything that I've been showing has been physical. So let's talk a little bit about what it looks like from a virtual environment. So impossible to synchronize VHDs live in 5 minutes, right? So it's just not going to happen. So I've taken the process and I've videoed it and I've edited it down to basically about 8 minutes. So we'll go and run that, and I will tell you what's actually going on in the video. Now, again, I know it's a little bit of watching a video within a video, and it's like holding up a mirror to another mirror, but at the end of the day, this is how to get the point across and show you how it's actually working in a time respective way. So we'll go ahead and start things off. You'll click on Recovery Services in Azure, and that'll bring up a site vault, and you'll go ahead and name that vault. Now be sure that you choose a region in which your servers are already located. If you choose a region that is outside of where your physical servers are, so if you're in, let's say, the US West, physically you want to choose the US West region. Otherwise the time date stuff will be off and things get a little bit funky. So just make sure you choose that correctly. So you'll see that the vault gets created here, and I'll go into that vault. And you'll see those right after this quick little survey. You'll see those step-by-step numbered checkboxes or steps, tasks that we have to do. So we'll go ahead and fill this out, hit OK, and here we have our 1, 2, 3, blah, blah, blah. Now, by default, the only thing you wouldn't see is that middle one between on-prem site and VMware, which is highlighted now, servers and Azure. So that's that physical to Azure private preview. Everything else you will see. So in our case, we're going to set up a Hyper-V to Azure scenario. And again, you can do this in VMware, it doesn't matter. The first thing in our checkbox is to create a Hyper-V site. And again, it's really just a nested series of containers. So you're just creating the fact that you're going to be putting in Hyper-V VHDs versus something else. So that gets created. We'll go into that, I believe, here in a second. We'll go back to our dashboard, sorry. We'll download our registration key. This is a key that says, hey Azure, this VM host, this is legit. Like, I know I'm putting the key on my VM host. I know that this is all good. And you'll download the provider as well. So there's our vault creds. And the provider is the synchronization tool. That's the thing checking for the deltas in the VHDs and pushing those deltas based on what you choose up to Azure Site Recovery. So that'll go ahead and download, and we'll run that here in a second. So I run that, and the first part of this is really just dropping the bits, right? It's starting up the agents, dropping the bits, making sure that this step-by-step will actually occur when you fire off delta changes. The next part of it is doing all of the checking to make sure that it's a legitimate source and you trust it. Anything with proxy settings. In this case, in my example, I was doing it live over the web. You may or may not want to do that. It's up to you. If by chance you get to this portion and it fails, you probably want to go back and check that region part. That's where I had the most problems at. So it found that was my subscription, and it let me go ahead and create that certificate on the VM host. and then it registers that up to Azure for Azure Site Recovery to actually work. So it registers these servers, and then it's going to say, okay, you did a VM or a Hyper-V scenario. Where's your Hyper-V servers? So we'll go ahead and I'll show you where those Hyper-V servers are at. You'll see that I have a modest farm, 2 apps, 2 webs, and a SQL box. They're all off at the current. It doesn't necessarily have to be off in your case, but mine were off. So, okay, the next thing we need to do is create a protection group. So in the protection group, you're basically saying, of the machines that are on this VM host, which ones do I want to protect? You might not want to protect everything or pay for Azure Site Recovery for every single VM that's running on your VM host. So you pick a couple settings here, make sure you have the right subscription and the networking. And then here's where you're going to be selecting your waypoints, so they're kind of like snapshots. So think, example, you push a new patch and the patch bombs and you need to revert, but in that 30-second time frame you've already synchronized up to Azure. These waypoints, or snapshots for lack of a better term, let you hold a couple states of VMs in storage until they expire, so you can protect yourself against those types of things. You can choose when your replication time happens, so maybe you want to do that in the middle of the night. Make sure you're not pulling against resources in the environment. All right, so that configures and completes. So now we'll add which virtual machines we want to our protection group, and you can see I have all of them there. So I'll go ahead and highlight them and choose what kind of operating system they are, and this is really just some behind the scenes stuff for ASR that's going on, so you just really have to just select which type of OS they are and you can move on from here. Now just for disclosure, even with trying to streamline all this, I only actually synchronized one VM. So you would allow this process to finalize and complete all the way through all of your VMs being synchronized. But you'll see here in a second when I actually add the VMs to my protection group, I'm only adding one of the web front ends. Again, just for simplicity's sake, whether I'm adding 5 or whether I'm adding 1 or 10 for that matter, you sort of get the idea, right? So that's going and creating down there in the bottom right. Have to wait for that to finish. And there's actually jobs that you can check out to see what's going on behind the scenes. You can see that I have WFE2 up and running. I believe I check my jobs here in a second to kind of show you what's actually in process, if there's anything in process going on. One of the things you'll want to make sure that is you're waiting for all those jobs to be completed prior to actually going forward, otherwise it won't work. So you can see that I've checked all my jobs here, and it's really just a backwards list of all the things that we did in our checklist earlier, or we showed in our checklist earlier. So I'll create my recovery plan here, and the recovery plan is just the bucket of stuff that I want to recover if a DR happens, right? So I might have multiple farms within different recovery plans. That way maybe I just want to bring up internal production, or maybe I just want to bring up external publishing or something along those lines. So again, I only did one here. Again, you'll see all your VMs in there, and you can choose which ones you want to put in that recovery plan. It's sort of up to you which one you want to do. So that goes and it finishes up. And you can start to see things coming together. At the bottom, we have our test failover, our failover scenario, so we can just go at it at this point, minus a few things once we finish this actually up and running. So next we want to do is we can now choose. Now it's not super obvious at this point because I only have one of those VMs that I synchronize, but I can choose which ones I want to start when. And something you missed right there, if you look at the bottom, you can see scripts and manual actions and different groupings. I can actually write scripts against the ASR to do different things when boxes come up, notify somebody, or spin up SQL box first to make sure that's up and running, pause for 2 minutes, and then bring up a web front end server. You can do quite a lot of things at that point, within your own automation sets to make things happen. Maybe it's a report back to a system center box or whatever it might be. There's a lot of room for manipulation from a customization perspective. Now, you would just choose a failover at this point, and I don't test my failover, but you'll select which network you want to choose. I choose one of the many that I have here. And then that will fail over that test to that particular virtual network, so you can see how things actually go up and run there. So we showed you our demo. Hopefully that makes sense. Again, a very compressed demo, and hopefully that leaves you with a good, at least fundamental idea of what it's like for Azure Site Recovery. And now we'll open it up to some questions. Thanks a lot.